Hello everyone, I am Ansh and today I am going to represent my project EcoBreathe. The aim of the project is to improve air quality in dimly lit, cramped office spaces with no natural light and poor ventilation. This system, called EcoBreathe, utilizes sensors to monitor and regulate CO2 levels and employs activated carbon filter in the roots of the snake plant to enhance indoor air quality. Its goal is to create a more positive and lively work environment, promoting better health and productivity in spaces of around 100 to 200 square feet with a user friendly plug and play setup. The requirements of the project are really simple. It requires two AQI sensors for calculating CO2, VOC, PM1, PM2.5, and PM10 values. A microcontroller used Arduino Nano 33 IoT to control the pump and send and receive data values to the cloud. A Raspberry Pi acting as a server with GUI interface for user interaction. Hi guys, this is my project EcoBreen. What it basically does is that it purifies the air naturally using the snake plant right here. The mechanism is that the air is sent inside the snake plant's roots to the soil. It passes through the duct inside and gets exhausted out from here through the fan. It uses a carbon filter that is placed inside here. It has activated carbon in it. It is used to act as a catalyst for the air purification. Here is the water pump that is used to automate the system. Uh, this plant is totally self-sustainable. The water is pulled out from here directly up to here and is given to the plant. A soil moisture sensor that we use it is placed inside the plant here like this. This sensor gives the data to the Arduino Nano 33 IoT that has to be connected here, and it uses this data to check if the soil has enough moisture, and if the soil is lacking moisture levels, then the pump is turned on by sending a signal from the Arduino. The pump is automatic, so it will remain on until the soil required soil moisture level is reached. What it basically does is that it gives the data signal and the pump releases water on the plant. The water is taken out from this part, this water container, and this is the PMS sensor, PM2.5 sensor from here right now. This sensor right here is the AQI sensor. It gives VOC and CO2 values. These are the pump options for the GUI interface as shown. The pump can be automated and manually controlled. Firstly, it is automated and the sensor is providing data. Right now the pump is on because the sensor is kept out to give fake values. Now the pump is operated manually. Now the pump is off. As soon as we turn the pump on, it it will turn on without taking the data from the sensor. We are still getting the live data, but it is not connected to the pump right now. As soon as we hit the on button, the pump is turned on. This right here is the Arduino code and the database, Firebase Cloud database that receives the sensor values. This data is further shown in the GUI interface using this Python script right here. This is the GUI interface and it asks for the admin username and password. As soon as we hit the login button, here we have the previous data, live data, and the pump options. First, we will see the live data. This is the live data of the CO2, VOC, PM1, PM2.5, and PM10 values right from the sensor. And the moisture is from the soil moisture sensor, and the water level is the amount of water present in the container. It gives the value of 1 and 0. Like if the water is present, the value is 1. Otherwise, the sensor gives the value of 0.